I think that leads nicely into our next speaker from IBM, Roeland Nagel, who's part of the Smarter Planets initiative at IBM. IBM's been doing a ton on smart cities, and I'm sure Roeland will have a lot to talk about in terms of connecting to people in those cities. All yours.
Don't leave me just yet.
Okay.
I
can improvise.
Of course, I had to deliver my presentation a few weeks back. Of course, I made modifications. So the presentation that's on here is no longer the latest version. So let me try to open up this one. I do work at IBM. This is a Samsung.
It's irrelevant. This is lost. It's lost with Samsung. Here we go.
Okay. So the reason to change this, the version that was on this computer already doesn't connect to the things that were mentioned here. So I thought it's justified to take a moment to change this into this presentation. It starts off with a wider view on IBM and smarter cities, and it focuses on the thing that's in the booklet already, a case where we try to engage with the customer in reducing his water usage. I'm usually somebody who holds a microphone and walks a lot. I'm stationary here, so I'm a bit awkward. I use my hands a lot, and you don't see that behind the desk. So let's see if the clicker works. So alternatively, my presentation would be, Dad, you gotta fix that faucet, it's dripping too much. Which states what this presentation, at the end of this presentation, is going to be about. It's engaging with this customer to change his behavior. First, I'd like to start off with a broad view of smart. You see smart popping up all over the place for years. Of course, in IBM we do things a little different. We don't call it smart, we call it smarter. When we first started with what is smart, what is smarter, I made this slide for myself to be able to explain it to other people as well. Because when I made this slide, I got it, and I hope that other people would get it as well. So, when to open your umbrella? Well, I've asked this question to a lot of audiences, and the first sign is always, well, when it rains, you open your umbrella. And then you're 80% right. You're 80% efficient in opening up your umbrella. But it's not enough. You need to feed in more context to optimize that decision. And I think what smarter is about, gaining more context to optimize your decision making, be it operational, be it tactical, be it strategic or policy making. So it doesn't make much sense to open your umbrella when you're already inside. So an optimization would be, if I'm not inside and it's raining, you open your umbrella. But what if I'm outside and I'm going to be inside in the next 10 seconds? Well, it takes me longer to open my umbrella than it takes me to walk inside. So even that further optimizes my decision of opening my umbrella. If I know my umbrella is broken, don't bother opening it. Don't try it. Maybe I'll break something else. So that even further optimizes it. And the last, or before last, is I might not even mind getting wet. So if I do mind getting wet, I don't want to get wet, my umbrella is not broken, I'm outside, I'm not going to be in. But in the Netherlands, there's no use for umbrellas because it's always windy. And when it's windy, you see all those broken umbrellas laying on the street. In Delft, they developed the storm umbrella. I have one, it works perfectly. You can hold it with 2 fingers in gale force 8 and it doesn't blow out of your hands. It's amazing. But when you go through this example, when you think about this for an hour, you can always find new things, new parameters, new context that will make this decision whether to open up your umbrella or not a better decision. Now, the key is, of course, opening an umbrella, not so very interesting. But when you apply the same logic to a storm surge barrier, to open or to close the storm surge barrier, then it does make sense to optimize that decision because it costs millions. If you close it or you open it, it costs millions. So you need to optimize. So that for me is smart and smarter. And when I got that, it made sense for me to connect it to the three things we think you should do. You should be able to instrument things with sensors, to be able to gather that intelligence. You should be able to connect it, all those sensor types, interconnect, and then to do some intelligence work over that. So you have your algorithms to be able to say something on this decision and to optimize it. So that for me makes sense. So let's go into what IBM says on smarter water. We know, preaching here to the choir, as said before, don't need to go into this too deep, but water is important. Let's keep it at that. It's important for growing food, it's important for healthcare, energy, transportation. Companies like Coca-Cola, for them water is part of their critical supply chain. No water, no Coke. For them it's very important to manage their water supply. So we thought of smarter cities, smarter planet, and we say, well, in fact, this smarter cities thinking will leverage the information, will anticipate on the problems you have inside of cities, and not only in the drinking water area, but also in safety, in transport, in healthcare, and our smarter cities thinking is on a broad level, connecting all those expert systems to each other to be able to run your city more efficiently. That's what smarter cities is all about. This slide, I won't leave it on for more than 10 seconds. This is just a view. You can define your, what we did, we made a software product called Intelligence Operations Center. And this is the architecture for it. You are able to define your KPIs, you are able to measure all of your sensor and relate that. You have your event rules. This is a framework which should connect well with a lot of the expert systems that you already have. And we're not, IOC can be viewed as a hollow framework which you have to fill with your expert systems. So a Takadu and other systems provide the intelligence, and with this framework you are able to share it more with all the departments inside the city to optimize running your city. That's already more than 10 seconds, so let's skip. These are some of the engagements we've been involved in recently. My own focus is on the flood control 2015. Here in the Netherlands, we have that program with 8 partners. It's been running now for 5 years. That's my area of expertise. But what I want to focus on today is some research done by IBM Research with the city of Dubuque. So what I want to do is tell that story and hopefully trigger you to approach me later on to ask questions on the IOC platform, the Smarter Cities platform, or the piece of the story I'm going to tell you now. So the challenge in Dubuque, or anywhere else even, water and energy conservation is critical, but if you look at the supply chain from the well to the faucet, your focus, as an outsider, when I look at this industry, I see that the focus is on the technology part, so from the well to the faucet, but not very much behind that. And the last link in that chain, the consumer, is not really smart yet. So the challenge, If you look at all these, I googled some pictures, maybe you recognize it from your company. It is from a reservoir towards the faucet in all these examples, and my question is, where's the consumer? If the consumer is not in this equation, then how can you optimize? So the pilot I'm going to discuss is this Dubuque case, and if you don't know where Dubuque is, Dubuque is there. And this is not my attempt to be remotely funny, but I'll come back to why I'm showing this. Actually, it's a little bit down. But this picture might be more familiar to you. This is the United States, and this is where the city of Dubuque is. At the forefront of innovation in conservation, and this project was done with IBM research. So their hypothesis was informed and incented citizens are better able to conserve water. And they tested this hypothesis in a study. So let's look at informed. If that were a scale to be informed or not, what we do currently, or at least in the Netherlands, we give them once a year, we give them an overview. Say in 2011 you consumed 50 times that amount of water. Both of which are at a scale humans are not very good at. They're not good in years, they don't know how long a year is, or approximately, and they don't know how much 50 cubic meters is. They cannot relate to that. So what I'm saying is, if that were on one side of the scale, we need to move it to the other side of the scale, and to give them something that relates to a day, or an hour, or a minute, or 10 seconds. That means something. That scale of time means something to a customer. And then your consumption is in liters, which you can also picture. It's the size of a carton of milk. That means something to a customer. 50 cubic meters doesn't. So if that is one scale of the spectrum of informed, then we can move to the incented. On one side of the spectrum, we have zero incentive to economize your water. And on the other side of the spectrum, we might use sticks and we might use carrots. Sticks as in, I will give you a fine if you overconsume, if you fill your swimming pool in times of a drought, and carrots in ways of, hey, I'm rewarding you for your water conservation. So then, if we put these axes on in a model, please don't confuse this as a scientific model. This is my way of explaining to you how I interpret this research, which I also confirmed with the scientists. So we move the consumer from being unable to being able, and a logical way of doing that is with the smart metering, so supplying them with the smart meter, but not in years, but in hours or seconds. And on the other scale, we move them from unwilling to willing, and we can do that with analysis, games, and competition. So if we then look at an indifferent consumer, we move them to an engaged consumer. And you can go there via two routes. You can first enable them and then incentivize them, or you can do the frustrating route. First make them willing to change but unable, and then they might go back to indifferent because hey, you're making me want stuff and I can't do anything about it. Or you do it directly. That route is you can play with, but this model is something that they tested in the research. So what did they do? They equipped in this pilot. They equipped more than 300 houses with smart meters. 6 were extreme volunteers, as they call them. Every 10 seconds they would have an update on their water consumption. More than 150 households at a 15-minute interval, and 150 plus households with an hour interval. They fed that data into a gateway, into a cloud system with all those algorithms, And so two groups, they gave access to a portal. And this portal, they could see their usage. And the city of Dubuque could also look at that data. So what did consumers get out of it? Well, they could review their consumption, of course, understand the trends, get alerted about the anomalies, etc., etc. So giving them more insight in what they were consuming, why they were consuming so much or so little. And the city would also benefit locating waste and monitoring aggregate consumption, but also use this data to make other pricing policies and maybe to think of sticks and think of carrots to ask people to prevent peaks from happening, which would require expensive investments in the system. So the implementation part, this is the portal they had access to, in which you saw how your usage changed over time, what your rank was, which is kind of a gaming aspect of it. To see your rank, you want to improve your rank. To earn green points, another gamification element. To see your usage through time and to be able to spot leaks. If there's 4 liters of consumption an hour for many hours at a time, then perhaps you have a leak which the system then detects and alerts you to it. So here is one of the users, and here you see actually that throughout the day there is a constant flow of water in that household, and then the system says, hey, you might have a leak, you may want to report that, and they were able to find a lot of leaks that way. So lessons learned. Users become more mindful with water when informed and incented. If we look at a study done, a questionnaire, when people looked at their graphs, they could see the peaks and they could understand, hey, this is when I took a shower, this is when I did that. I understand why the peaks are there, and I understand the graph I'm looking at. And a quote was a person who saw that hey, this is my shower, this is where someone else took a shower, this is when I fed filled the dog bowl. Actually, that would be with a 10-second interval monitoring. Really look at what's going on in a household, and that you see also the game dynamics working of people saying to each other on the online portal, hey, why is your consumption increasing? You're going to make us lose. So please be mindful of your water usage. And people were also changing their water usage by installing a shower head that uses less water, or other water reducing equipment. Not because they were told so, but because they understood their water usage, and they understood that they had to lower their water usage. So the conclusion, you have to keep in mind that this 300 households were all volunteers, and they were already mindful of their water usage, but still more than 6% of water reduction was reached with these users. And the engaged users, this was engaged users over the enabled users. So all of them had smart meters, but the ones who got access to the portal and who were incentivized and who had the game dynamics used 6.6% less than the people who just had the smart meter. So smart metering alone is not enough. So if you get your consumer to the state, as in, Dad, you got to fix that faucet, it's dripping too much, then you know you've got an engaged customer and you can work with them and optimize the full chain. So optimizing that part of the chain which the utilities focus on now. So from the source to the faucet, that's only part of the solution. A very important part, no doubt, but the real optimization comes with the full chain, and that includes the consumer as well. Thank you.